the linear inequalities separately, and then after that look at the number line, see where they overlap to finally get the answer. Okay, we will look at practice now 3. Okay, let's start with question 2 first. Okay, just to have a recap of what we were doing. So we want to solve this set of inequalities. In order to solve this inequality, right, okay, which looks a little bit different from what we were seeing yesterday. We saw it as 2 separate linear inequalities. Now we see it as one whole string, okay, with 3 different quantities linked together with 2 separate inequalities. Okay. What we need to do in such cases is that we need to break it up into 2 parts. Okay. So let me just write here. You have y minus 2 over 3 less than 2y plus 1 over 5, because I can only solve inequalities when it is separated out into 2 quantities. Okay, and then the other one, okay, I will take this as a second inequality to solve. Okay, so only when we have it like that, okay, then we can go about solving. Alright. First inequality over here. Many of us, okay, I don't know whether it's many of us, but I think some of us might think of trying to do cross multiplication. Am I right? Anybody has the idea of doing cross multiplication? Okay. Now this is an inequality. We need to be very careful about this idea of cross multiplication. Usually for cross multiplication, we do it for equation when it is an equal sign. Okay. Now for our inequality, right? Okay, some of you don't do cross multiplication the same way that I do it, whereby you have your 5 over here, y minus 2, and 3 over here, 2y plus 1. Okay, some of you don't write it this way. Some of you, in fact, cross the other way round. Okay, you will have maybe 3 and 2y plus 1, and then after that, 5 and y minus 2. Okay, clearly when I compare it side by side like that, we know that these 2 statements are different. Agree? Okay, so it is dangerous to think about cross multiplication. Let's put cross multiplication and keep it to just our equations only. Okay? When it comes to inequalities, what I want us to think about is trying to balance both sides of it. In this case, to get rid of the denominator, we will multiply by 15 on both sides, because 15 is the lowest common multiple of 3 and 5. So multiplying by 15 on the left, I will get 5 and y minus 2, and multiplying by 15 on the right, I will get 3 times 2y plus 1. Okay, so we try to think along the lines of balancing the inequality. Okay, where we do the same thing on both sides. Alright, rather than thinking along the lines of cross multiplying. Okay, because I am not sure who does cross multiplication the same way as me. Right? Some of you don't do it the same way. Alright? Then, once we arrive at this, the steps will remain the same as how we usually solve an inequality. We expand it. And then we arrive at y more than negative 13. Because this is negative y, we need to bring it over. That will cause the inequality to flip. Okay? So that is for the first set of inequality. For the second set of inequality, okay, I will multiply by 5 on the left, 5 on the right, and that will result in a 15. And then we get y less than or equals to 7. Okay? Alright? Now at this juncture, before I give you the final answer, okay? Yesterday at the end of the lesson, some of you did came to me and asked me, Okay, is it possible in this case, right? Okay, to write it as one entire inequality. For example, writing it. Okay, how will you write it up? Y. Okay, actually this makes sense. Wait. Y less than equals to 7. Y. Does it work for this one? Okay, no, it doesn't. Sorry. I'll come to that example when I see a problem. Okay, so from here, right? Sorry, I take back what I was telling you to say just now. Okay, so we will draw a number line -13 and 7. Then after that, y more than -13, there will be open circle to the right. And then y less than or equals to 7, close circle to the left. Okay? When you draw your lines long enough, you will be able to see the overlap much clearer. Like that. So therefore, our answer will be -13. Open circle, so it is strict inequality. Y. Close circle, so there's equal sign, and then to 7.
Close circle.
We usually, it's a close circle here. Because it's an equal sign here. So, usually we write our inequality from smaller to larger, okay, rather than the other way round. Okay. Yeah. We have to write 0, not necessary. Yeah. Okay. I know that in the past sometimes your teacher may actually require you to write 0. Okay, that is more for us to distinguish between your negative numbers and positive numbers. Yeah, but it's not necessary to have to doing like that. Okay. Yeah. This is just shading. To do the overlap, I will encourage you to do that because when we go into A-maths, you will see that it's very helpful. Okay. Questions? So take note that our inequality sign need not always be the same sign throughout. Okay, it can be one less than the other one less than or equals to. Right? So it depends on the question itself. Next, we look at question 1. Okay, I reverse a little. Okay, could I just give you 2 minutes over here? Okay, work on the separate inequalities. Okay, when I separate it out. Okay, then after that, work them separately, then after we will see how we arrive at the final answer. Okay, I'll just give you 2 minutes to work on that. It shouldn't take long.
Why does he keep falling, bruh? was feeling at least support people
I'm just telling you the song up here only. Okay? Are we able? Wait, yeah, okay, ready? Yes. Okay? Are we able to arrive at this?
Yes.
Yes? Okay, now, you may find that there's a problem over here because if you want to represent it on your number line, what does it actually look like? Okay? So we notice that, okay, we have -4 over here. X is less than or equals to -4, pointing in this direction. For the other one, it is x more than 8. And this will be open circle pointing in the other direction. Okay? There's clearly no overlap at all. Agree? Okay, so in this particular case, the conclusion that we have is that there are no solutions. Okay? So we will say there are no solutions that satisfy the inequality. Okay? So we must be familiar and be able to accept that there are cases whereby there are no solutions. Okay? Writing that there are no solution is a solution in itself. Okay? So a little bit tricky in understanding over here. Writing no solutions is a solution to the question itself. Okay? So you must write down this statement. Okay? Questions? Now some of you might be wondering, would I actually write something like that? Okay? Just because over here we see that x is greater than 8, which we identify here. Okay? Then after that, x less than or equals to -4 is actually seen on the other side of this inequality. Okay? But the entire inequality itself, does it actually make sense? It doesn't. Because how can you say that 8 is less than or even equals to -4? You understand? By reading this entire inequality, this number here and this number must make sense to the entire statement also. Okay, so 8 is not less than -4, neither is it less than or equals to -4. Okay, so you cannot write it in such a manner. You understand? Okay. So actually, we always have to draw a number line and then after that arrive at our answer, which is that there is no solution. Okay, so that's for chapter 2.1. We next look at 2.2. Okay, I want us to read practice down more in your textbook page 45 while I write it on the whiteboard. okay, involving simultaneous linear inequalities. Previously, when we were in Set 2, we learned how to solve problems like this, maybe by creating simultaneous equations. But now we're trying to make use of inequalities because there are statements or phrases found in the question itself that requires inequalities to be introduced. Okay, so let's try to pick out and identify what are the important information that's given in the question. It first says that there are altogether 48 20-cent coins and 50-cent coins in the box. So we know the total number to be 48 coins in total. Okay, then the total value is more than $12. So we're talking about the value itself, not about the number of coins. And it is more than $12. Okay, so because of the word more than, that's where we know we have to introduce the inequality, of more than. And then the number of 20-cent coins is at least twice the number of 50-cent coins. So again, this is a crucial information. Okay, number of 20-cent coins at least twice the number of 50-cent coins. So perhaps you may want to just write it in symbols first. Okay, at least, alright, what symbol are we looking at? Less than? Or more than? Or something else? More than or equals to, right? Okay, so more than or equals to twice the number of 50-cent coins. So twice means 2 times number of 50-cent coins. Okay, we want to find a possible set of respective numbers, respective number of 20-cent coins and 50-cent coins in the box. Okay, so we have an idea that our two inequalities that we can form will rely on this statement over here as well as this statement over here. Okay, so how do we introduce the variable that we want to do, that we want to use to answer this question? Okay, so in this case, we're trying to find the number of 20-cent and 50-cent coins. So naturally, what we'll do is we let x be the number of 20-cent coins. Okay, so let me just stick with what I already had. 50-cent coins and I left a blank over there, for the number of 20-cent coins. I can definitely let it be y, but are we able to write y in terms of x for the number of 20-cent coins? Okay, we know that there's a total of 48 coins, right? Okay, so if x were to be the number of 50-cent coins, that will mean that the number of 20-cent coins would be 48 minus x. Right? Okay. So from the very first statement, which I indicated over here, we say the total value is more than $12. Okay, this is in dollar, whereas our coins are in cents. So when we form an equation or inequality, we must ensure that the units are the same throughout. Okay, so in this case, if there are x 50-cent coins, and I want to express it in dollar, the value of it will be x times 0.5. Yes, Jaden?
I don't understand why is it 48 minus x.
Because there are 48 coins in total. So if there are x number of 50-cent coins, then the remaining will be 20-cent coins, right? Okay, so x times 0.5 will be the value of the 50-cent coins, and then the value of the 20-cent coins will be 48 minus x times 0.2 or 0.20. Okay, the second decimal doesn't matter. Okay, so this is the value of all the coins, and it is supposed to be more than $12. Okay, so that's how we can form our first inequality. Right? And then we can simplify it to 0.5x plus, we expand this 48 times 0.2, that will arrive at 9.6. Okay, minus 0.2x, which further simplifies to 0.3x more than 2.4. and x is more than 8. Okay, maybe just to be clear, 12 minus 9.6. Inequality which we derived from the first part of the question. And in the second part of the question, okay, it says the number of 20-cent coins is more than or equals to 2 times number of 50-cent coins. We're looking at the number of coins, not the value. Okay, so number of 20-cent coins, we know that it is 48 minus x already. It has to be more than or equals to 2 times the number of 50 cents, so 2x. Okay. So in other words, 48 more than or equals to 2x plus x. That is equals to 3x. So 48 divided by 3, that's 16. In other words, x is less than or equals to 16. Okay. So with that, we are able to then determine what are the possible values of x by drawing our number line. So we have 8. X is more than 8 will be represented this way. X less than or equals to 16. Okay, close circle, the other direction. Okay, I'm shading over here. That's why all these diagonal lines are. Okay, such that my x will be between 8 and 16, where 16 is inclusive, 8 is not. Yeah. Where did the 2x come from? Because the question says 2 times, twice the number of 50 cent. 50 cent coins is x. The question says twice. So 2 times.
Then why didn't we put 2x?
Huh?
Why didn't we put 2x?
Why didn't we put 2x?
Like for the number of 50 cent coins.
For the number of 20 cent coins. The number of 50 cent coins is x. So number of 20 cent coins is 48 minus x. The 2 over here is because of this word twice in the question. The question is saying that the number of 20 cent coins is at least twice the number of 50 cent coins. So that is 2 times. Questions? Am I answering your question? Yeah.
What is a 2x times, right, for the 20 cents? But why is it for the 50 cents?
Because the question says twice the number of 50 cent coins. Yeah. That's the meaning of that English sentence. For example, if we say there are twice as many boys as girls in this class, what does it mean? If there's 1 girl in this class, how many boys are there? 2, right? So twice the number of 50 cent coins.
Like for the
2x here.
For the number of 20 cent coins is more than or equals to 2 times of the 50 cent coin.
50 cent coin is x. Not 2x. 2 times is twice. Correct? 2x is 2 times x. I don't understand your cursor over here. This is number of 20 cent coins. More than or equals 2 times number of 50 cent coins. If this will define this and this will define this way.
Wait a minute.
Oh, okay. I think it's saying that he said you're asking why down here we don't write let 2x be number of 50 cent. See? But that would be very confusing when you do that. You understand? if the number of 20 cent coins is at least twice the number of 20 cent coins. Because the twice is for the number of 50 cent coins.
No, they said at least, so it can be more than.
More than, at least means more than 50 cent. You try to think about it. Anybody else also have that same problem? Okay. I think it's a method translating an English statement into text. Okay. Are most of us able to understand it? Okay. Queenie, just now you had a question? Okay, so we get this, but that's not yet the answer. Okay, question is asking, find the possible set of the respective numbers of 20 cent coins and 50 cent coins in the box. Okay, so possible numbers. Now our x, which is the number of 50 cent coins, can either be the value of 9, 10, 11, all the way to 16. Okay, based on this inequality over here. So, number of 50 cent coins equals to 9, 10, 11, 12, 13, 14, 15, 16. We understand why these are the possible numbers. Okay, it cannot be because x must be greater than 8. And they must all be whole numbers because we're talking about number of coins. You cannot have 1.5 a coin. Right or not? Okay? So, then the number of 20 cent coins. Okay, that is actually possible. If your number of 50 cent coins is 9, number of 20 cent coins will be 48 minus 9. And that will give us 39. Right? Okay. Then after that, if it were to be 10, 48 minus 10, that will give us 38. So we can go down the list. Right, these are the possibility for the number of 20 cent coins. The question is actually rather open. They just want you to write a possible set. Okay, so you just have to write one of the option, one of the possibility. That is 9 50 cent coins and 29. Otherwise, you can choose other pairs. Okay, you can choose 30 50 cent coins and 35 20 cent coins. That's also possible. Okay, so any combination is possible over here. Right, so this question has an openness in terms of its answer. Okay, questions?
Why you cannot let x be the number of 20 cent coins? Like how you know you make it? How
You can do that.
Oh, cannot.
You can let x be the number of 20 cent coins. I never say cannot. Yeah. You can do that, just that it will then the inequalities that you get will be different. Yeah. Your solution will then be in terms of 20 cent coins. Yeah. You can do that. Not a problem at all. Yeah. Okay, it's just what happened because the one that I really prepared, I really find it this way. So I didn't want to cause myself a confusion when everything. Okay. Any other questions? Alright? Yeah. Okay, then I don't Okay. If not, I want to let you copy another question. Okay. Just for us to really understand this. Okay.
There's no way I'm doing that.
Okay, I give you a minute to copy that.
Bye bye. Of course it's Raj. I say Raj, not Muhammad.
Okay, we look at this question now. Alright. So reading form of understanding inequalities. Okay, yes, Alex. Wait, you want to ask just now the question? No, as in this question. No, I will go through. Yeah. Okay, I only want you to copy the question. Okay, if you already tried, then good. Okay. So let's look at this question. Okay, so we need to understand that operation we're looking at is plus. Okay, and it is actually plus 3 points when it is correct. When it is wrong, okay, there are points being deducted and the operation we think it to is minus, so it is a minus 1 point. Okay, regardless of whether you when you actually don't answer a question, okay, you will not be awarded, neither will you be deducted any points. So actually no points will mean that it is just a 0 lah. Okay, so this is the information we can gather so far from these statements. It says here that Rush attempted a total of 19 questions. Okay, 19 questions. That means that there's one question that is unattempted. Because total is 20 questions, right? Okay, so one question unattempted. Okay. Now, his total score for the IQ test was above 32. Okay, we want to find out the minimum number of correct answers he obtained. So this is a critical information that the total score was above 32. Okay, so the total score is more than 32. That is what we can get for this. Right? Now, how do we find the minimum number of correct answers obtained? Since we're trying to figure out correct answers, let us define that unknown be x. Okay, so let x be the number of correct answers. Okay, so how many questions are incorrect then? 19 minus x, okay, because only 19 questions were answered, not 20. So do be careful about that. Okay, so 19 minus x, okay, are the incorrect answers. Okay, so we are told that the total score is more than 32. How do we find the total score? We need to find the value, okay, based on the number of correct and incorrect questions. Okay, for each correct question, 3 points were added. Right? So that means the total value over here will be 3x. 3 times of x. And then for your incorrect answers, okay, it is actually a deduction of 1 point, so minus 1. There were 19 minus x incorrect questions, so minus away 1 times of 19 minus x. Okay? For the unattempted question, it doesn't matter. We do not need to put it into this expression because eventually it is just a 0. Alright? So I'll just put it here in case you didn't catch what I said. Okay, so this is the unanswered question. So this is correct. Incorrect. Or unattempted. Okay, so this is the total score that Raj managed to get, and it is actually above 32. Okay.
I thought it's above or below.
Sorry, never said
Oh, never mind.
Okay. So now we can solve it. So we get 3x minus away 19 plus x more than 32. Okay, and that is 4x minus 19 more than 32. 4x more than 32 plus 19. Okay, I'll write it up here. Okay, so we get 4x more than 3, 4, 5, 51. Okay, so x is more than 12.75. Right? But the question is saying, find the minimum number of correct answers. So what is the minimum? It will have to be 13. Okay, it must be a whole number. Okay, that's why the answer is 13. Alright, questions? Yeah.
We round up and round down.
It's not about rounding, okay? We are not about rounding, it is because of these inequalities. It says x more than 12.75. So we look at the first integer in the inequality. Okay? So not about rounding off. Okay? One last question, not a problem sum. Okay? But before I erase this, any problems or any questions that I'd like to ask? Yes. Because minus 1 1. Because the question says what's our problem? One more. Just to wrap up our understanding of inequalities. Okay. Exercise 2A, question 6. Question says that x is a prime number. We want to find the values of x for which it satisfies the inequality. Okay, so we solve these two inequalities separately and then we identify what x should be. Alright? Would I give you 3 minutes to work on this to find out the solution? Inequality at the end. Okay? The inequality at the end is not about following the signs over here. Okay? It is not about following these signs. Okay? It's not like you just put 24, then after that copy the same sign, and then after that you write like that. This statement itself doesn't make sense. Because how can 48 be, or rather 24 be more than 48? Right? I also don't know how to read this inequality, this statement itself. Okay? It doesn't make sense. So how we get the eventual answer is based on this number line, where we see that our values is in between 24 and 48. Okay, that means it is bigger than 24. So x is bigger than 24, but smaller than 48. Smaller than 48. Okay? Our inequality sign, the opening, always faces the bigger number. Okay? So that's how we get this final inequality here. But the question is asking for the prime number x. Okay? So the prime number x, we need to Okay, 30 isn't 31, 37, then 30, no more, 41, 43, 47. Okay, is there any more? Right, so these are all the possible prime numbers. Okay. Alright, so that's all for our chapter 2, exercise 2A. We will homework question 3A, 4B, 7, and 9A. Just these 4 questions. Okay, this shall be due. Friday, what I gave yesterday was due tomorrow. You was Thursday, right? Okay. This one due Friday. Friday can okay, due Friday. Let's not procrastinate further, there'll be more. Okay. Tomorrow, before we end the class, I said, sit down, okay? Tomorrow, please make sure you bring your A-Maths materials. Going to A-Maths, bring your A-Maths textbooks, okay? So, younger, I know you don't take A-Maths, you do homework. Okay?